Thanks again, Kat. Good morning, everyone. My name's Doug. I lead a research team at Google focused on generative AI. That's a class of models unlocking creative agency. I've been doing this for a long time. In my 25 years in this career, I've never seen quite so many advances in the generative space as I've seen in the last few months. The pace of innovation is truly incredible. So today, I'd like to take the chance to show you some of our research. All through history, technology has been used to express ourselves. We have the printing press, we have the film camera, we have even glass blowing. And we hope to extend that tradition by building tools that organize information, foster creativity, and preserve creativity. So whether it's about finding something new or making something new, Google's here to help. And there's no better example of this than generative AI. These models can generate text, code, audio, images, video, and so forth, which can have a big impact on unlocking creative potential. And I think one of the most important breakthroughs in the last year is models that give users control over this process. It's about control. It's no longer about generative models that can just generate a realistic picture. It's about being able to make something that you've created yourself with a text prompt or some other input. And I can't stress enough how important this control can be. Why? Well, because I'm sort of an artist myself. My bachelor's degree, pretty rare for Google, is in English Lit, creative writing. I moved into science later. I play guitar and piano. For the guitar geeks there, that is a right-handed guitar flipped upside down. I'm a lefty with an extra pick guard added. I'm not a professional at any of this, but it brings me great joy. So to me, it's essential that we be honest to the creative aspect of what we're doing. Technology should serve our need to have agency and creative control over what we do. There's always been interplay between art and technology, but generative models now are different than the electric guitar. That's because they can actually move us deeper into our creation process to help us compose, edit, and generate new raw materials. In turn, this gives us new ways to make art and music, which I'm very excited about. So let's start. Some examples. I'd like to start with assistive writing. Last year, we introduced Lambda, a dialogue engine enabled to engage users on a number of topics. Then a few of us at Google started to wonder how we might use Lambda for creative writing. And this led to our research question. Could a dialogue engine like Lambda assist writers with storytelling, or even generate new ideas to help us get through writer's block? And that research question became the inspiration behind our WordCraft Writers Workshop. We challenged a number of professional authors to write experimental fiction using Lambda as a tool. I thought the stories were great, and I hope you will too. We'll be releasing them along with our research paper soon. One clear finding was that using Lambda to write full stories is a dead end. It's a much more effective tool when it's used to add spice, a particular character, or to enhance an aspect of the story. We also learned that the user interface has to be right. The WordCraft tool you are seeing here was designed from the ground up to enable writers to interact with generative models. Think of it as a text editor with a purpose. Without it, it would be impossible for the writers to do their work. I'm really excited about the quality of the writing. I think you'll enjoy reading these stories as much as we did and learning how Lambda played a role in the creative process. I invite you to look at their work. You'll see 6 of them on this slide, and you'll find more at this link. Now let's talk about code. We're also exploring how AI can assist in software development. Again, let's make the connection back to writing. Developing code is a lot like creative writing. And our Learning for Code project, more concretely, is exploring how to generate AI code suggestions by combining language models with code repositories. We tested this internally at Google by giving our developers single-line and long-line code completion. It's still in early days, but we've already seen an improvement in coding iteration time by 6%. Let's switch to audio now. Google recently introduced Audio LM, a framework that can generate high-fidelity speech and music by continuing from a small audio sample provided by the user. This provides us with control over the output, making it much more than push-button audio generation. Let's take a listen to this Audio LM clip. One thing that excites me about Audio LM is that it doesn't require expert annotation. In this example, there was no need for a musical score. It continued the audio directly from the audio in the space of audio, and it can work with any audio clip you ask it to extend. The creative applications here are exciting to imagine. Now I'd like to dive into a topic that's probably most visible and popular, text-to-image models. To quickly set up context of how far we've come in 5 years, take a look at these AI-generated images from 2014, 2019, and now today. Earlier this summer, you were introduced to Imagen and Phenaki, two different models that both have an impressive ability to generate images from text prompts. These models take different approaches to text-to-image generation. Effectively, Phenaki is more about the text in text-to-image. It uses language modeling to generate an image directly, and turns out it's really good at listening to the prompt and making the right image. For example, here the prompt is a dignified beaver wearing glasses, a vest, and a colorful necktie. He's standing next to a tall stack of books in the library. And as you can see, the model captures that intent. Imagen is more about the image in text-to-image. The underlying technology, diffusion, is good at generating images with ever-increasing resolution. The basic intuition here is that diffusion learns to generate structure from noise. So why two approaches? Because we never know when research wins will happen. We really don't know what's going to work until we try. And we're very happy to have two teams try two different areas. This time it happened that both approaches worked really well. We're also working on creative new ways to use the core technologies developed in Imagen and Phenaki. Our Dream Booth project is like a personalized photo booth. You choose the subject. In this example, I've selected an image of a corgi. Dream Booth lets me drop in the corgi image into almost any setting I can imagine, for example, in the Acropolis. Another recent breakthrough that I'm really excited about is that some folks in Google Research took diffusion models and applied them to the task of 3D rendering. This is called Dream Fusion. What you're looking at here are 3D images rendered using diffusion, and those 3D images can even be pulled into 3D software and animated. The last area I want to touch upon is text-to-video generation. It's surprisingly hard to generate videos that are both high resolution, that is, spatially, the images look crisp, and are coherent in time. That is, the sequence of images that unfold tells a coherent story. We have two complementary research approaches that tackle both of these: Imagen Video and Phenaki. Imagen Video uses the same diffusion technique that's used in Imagen to create really crisp individual images that can be used to generate short videos. Phenaki, on the other hand, uses a language model that generates tokens over time, which allow the model to pull together a long-form, coherent story. But the real magic happens when you combine them. I'm excited to show you our first rendering of a super-resolution text-to-video generation. A blue balloon stuck in the branches of a redwood tree. Camera pans from the tree with single balloon to the zoo entrance. Camera pans to the zoo entrance. Camera moves very quickly into the zoo. First-person view of flying inside a beautiful garden. The head of a giraffe emerges from the side. Giraffe walks towards a tree. Zoom into the giraffe's mouth, of course. Giraffe gets close to a branch and picks a blue balloon. A single helium blue balloon with a white string is flying towards a giraffe's head. Giraffe chewing with the blue balloon nearby. Camera tilting, following the single blue balloon flying away. I didn't build this. I'm sorry, I think this is amazing. I genuinely think it's amazing that we can talk about telling long-form stories like this. What's exciting about this is that we can generate super-resolution video from not just one prompt, but from a sequence of prompts, effectively giving us a new way of storytelling. Video generation is in its infancy. I'm particularly interested in better understanding how filmmakers, or even video storytellers, even maybe me, might make use of this technology. We're also thinking about creatively combining some of these things for everyone to experience. Earlier this year at Google I/O, we announced AI Test Kitchen. It's an app that gives people a place to learn about, experience, and give feedback on Google's emerging AI technology. Today, I'm happy to announce that we're working on new AI Test Kitchen experiences featuring text-to-image generation. You can build themed cities and design monster characters, all using text prompts. These experiences will be coming soon to the AI Test Kitchen, but you can get the app now from the Play Store or the App Store and start using Lambda. Okay, let's take a step back. Generative AI models are powerful. There's no doubt about that. They have the potential to give us a completely new level of expression and artistic control. But we also have to acknowledge the real risks that this technology can pose if we don't take great care, which is why we've been slow to release them. And I'm proud that we've been slow in releasing them. So obviously, there are some issues here I want to discuss around toxicity, disinformation, and bias, which could lead to overall trust in our media and news. It should be clear to folks like journalists, we don't want to make it even easier to blur the distinction between what's real and what isn't. There are a lot of open questions related to how this technology will impact the professional lives of creative people. We want to be very careful in how we build data sets and user experiences. In terms of acting responsibly, our research teams have been actively integrating Google's AI principles into our work. We're focusing on 3 key areas. The first 2 are about control. We want to provide controls for generating media. For example, we want to minimize the generation of toxic or violent media. And we also want to provide users with control to do stuff they really like, to be really creative. There's a lot of work going on to create appropriate interfaces and user experiences in controlling these models. There's also the question of controlling this media once it's created and disseminated on the web. We want to be sure we can detect synthetic media. We've been working really hard across the board on that. For example, I'm happy to say that we've made some progress. In our audio LM work, we trained a classifier that can detect synthetic speech with nearly 99% accuracy. So we're going to continue to be working on these 2 forms of control. First, when media is created responsibly, and when the media is disseminated, we have ways to detect it. Finally, it's important that we engage with the communities to build for everyone. We want to continue to work with writers, artists, musicians, creators, to understand their needs and to understand how to build tooling that matters for the community. So to conclude, creativity is an important part of what makes us all human. I think it's important that we keep this in mind when we're building these AI systems. Now I'd like to turn it over to Zubin to talk about how we're advancing AI through language.